This video is going to go over some important circle theorems. The theorems that are going to be in this video are intersecting chords, the lengths and the angles, and the lengths and the angles of tangents, secants, and a combination of those. So let's take a look at this first example over here. Over here, I see that we have intersecting chords in the circle, and we're told that AE is 2. We're told that CD is 9, and that CE is 4. So we need to find the length of BE. So we're talking about segment lengths here. So for segment lengths, our formula is part times part. So that's of one chord. So each part of one chord is equal to part times part. So that's each part of the other chord. So I don't want this labeling to get weird, so I'm going to redo so it's a little bit easier to understand with my different colors. So let's start with this chord over here first. So one part of it is 2, and the other part, BE, is what we're trying to find. We don't know what it is. So we have 2 times X, the part of this chord to the intersection, and then the other part after the intersection. Okay, then CE. CE is 4, so that's one part of CD. And then I need the other part, which would be ED. They don't tell me what ED is, but they tell me the whole CD is 9. So that means this part has to be 5 to make 9. So what I have here is that 2x is equal to 20. So x is equal to 10. So the length of BE would be 10 units. Let's try another example. So it says in a circle, chords AB and CD intersect at point E. AE is x plus 1. EB is x. CE is 2. And ED is 3. Find the value of x. So once again, we're talking about the segment lengths formed by intersecting chords. So we're going to use part times part equals part times part. The two parts of this chord are 2 and 3. So 2 times 3. And the two parts of the other chord are x plus 1 and x. So this is 6 is equal to, let's distribute that x squared plus x. Ooh, this doesn't work out nicely. We have a quadratic. So I'm going to have to factor here or use the quadratic formula. So I'm going to make my equation equal to 0 because that is how you set up for either factoring or the quadratic formula. And I'm looking for factors of -6 that add up to give me -1. So I'm thinking 3 and 2. One of them has to be negative to make a -6, and they should add to give me a positive number. So I want the bigger one to be positive and the smaller one to be negative. That multiplies to -6, that adds to -1. So my two factors are x plus 3 and x minus 2. Now, if you take each of these factors separately and solve for x, we have x equals to -3, and we have x is equal to 2. Now, it doesn't make sense that a segment length in a circle would be negative because then we wouldn't be able to see it here in our diagram. So we reject the negative, and our x value here is 2. This next question is a little bit different because already I'm seeing degree measurements on the arcs. And the question's asking me if I just look at the bottom really quickly to find an angle. So I'm talking about the angles and the arcs formed by intersecting chords. So notice when we have intersecting chords, they create vertical angles because any intersecting lines create vertical angles, and vertical angles are always congruent. We need to find the measurement of this vertical angle over here, but we know that whatever this one is, this one will be the same thing. So whenever you have intersecting chords, the vertical angles are equal to half the sum of their intercepted arcs. So angle C that I represented as x, is equal to half the sum, so that means of its intercepted arcs. This vertical angle opens up to the 87-degree arc, so that's one of its. And this vertical angle opens up to the 35-degree angle. That's its other intercepted arc. From here, all that we have to do is get our calculator out and type in 87 plus 35. I got 122 and divide that by 2. And I got 61 degrees. So this vertical angle, and that means its other vertical angle over here, congruent vertical angle, will also be 61 degrees. Okay. Notice how once again we have intersecting chords, and we're talking about arc measurements and angle measurements again. I already see that from the labeling. And the question is asking me to find the value of x. So I know that the vertical angle formed by intersecting chords is equal to half the sum of the intercepted arcs. One of the intercepted arcs is 120, and the other intercepted arcs is 2x. Multiplying both sides by 2 to cancel out the 1/2, we have 8x is equal to 120 plus 2x. Subtracting 2x from both sides, 6x is equal to 120. 120 divided by 6 is 20. So I have x is equal to 20. And that's what the question was looking for, my x value. It didn't ask me to plug in anywhere. Now we're changing it up a little bit because now we don't have intersecting chords anymore. So the situation is going to change a bit. I see here that I have 2 secants to the circle. And I know these are secants because they're lines that intersect the circle at 2 spots. So I have 2 secants here that meet at point P outside the circle. So I have an outside angle here. And I see that they tell us in the question, angle RPS is 35 degrees. So they already give us what the outside angle is. And they tell us arc RS is 121 degrees. Determine and state the measure of arc WT. So whenever we're dealing with an outside angle formed by either 2 secants, 2 tangents to a circle, or a secant and a tangent, it doesn't matter. It's always the same thing whenever we have an outside angle. The outside angle is half the difference of the intercepted arcs. So instead of doing addition, like when we were doing the angles of intersecting chords, we're going to be subtracting. We're going to do half big intercepted arc minus smaller intercepted arc. And what I mean by intercepted arc is if I look at the rays of this angle, notice that this arc, WT, is inside the rays, so that's one of its intercepted arcs. And this arc, RS, is also inside the rays of the angle, so that's its other intercepted arc. So I know that the angle, the outside angle, which here we know to be 35 degrees, is equal to half the difference of big intercepted arc minus smaller intercepted arc. And if I multiply by 2 on both sides to cancel out the 1/2, I have 70 equals to 121 minus x. 70 minus 121 is negative 51. And dividing by negative 1 on both sides, we have x is equal to 51. So the measure of arc WT, which was represented as x, is 51 degrees. Here we have another example, and once again, I see that we are talking about an outside angle, and this time we have a secant and a tangent that make that outside angle. But it doesn't matter, it's going to be the same exact thing. The angle, the outside angle, is half the difference of the intercepted arcs. They tell us here that the ratio of arc AC to BC is 7 to 2. So I'm going to represent AC as 7x, that's the 7 part of the ratio, and BC as 2x, that's the 2 part of the ratio. And I know that altogether, both of these arcs need to make 180 degrees because it's half of a circle. So 7x, 2x arc need to make 180 degrees. That's 9x is equal to 180, so that's x is equal to 20. Plugging in, 7 times 20 is 140. So this arc over here is 140 degrees. And that makes this arc have to be 40. And that's what 2 times 20 is anyway. And we are looking for this angle over here. So now I can use my theorem that we just had, our rule, to set up an equation to solve for the outside angle. The outside angle, which is angle P here, which we represented as x, is equal to half the difference of the intercepted arcs. So one of its intercepted arcs, the bigger one, is 140, and the smaller one is 40. 140 minus 40 is 100. Half of 100 equals to 50 degrees. So the outside angle, angle P, is 50 degrees. The last new theorem that we're going to talk about in this video is the lengths of secants and tangents and combinations of the above. So here we have a secant, two secants, because they both intersect the circle at two spots. And we're dealing with lengths here. I don't see any angle measurements. I don't see any arc measurements. I don't see any degrees. Instead, they're giving us segment lengths. They tell us that RS is 6. They tell us that ST is 4. And they tell us that RP is 15. And we need to find the length of RQ. So whenever we're talking about the lengths of secants, tangents, or a combination of any of the above, secants and tangents, the way that we're going to do that is we're going to use the rule whole times outside equals to whole times outside. And once again, this is anytime you have secants or tangents and you're talking about their lengths, the lengths of the segments themselves. I should represent this better. I meant to do a question mark, but I'm just going to use an X because that question mark kind of looked like a set. So let's start with the secant over here on the top. So the whole secant would be 4 plus 6, so that's 10. And the outside part would be 6. Now let's go to the other secant, this one over here. So the whole thing was given to us as 15, and the outside part is what we're finding. That's x. So here we have 60 equals to 15x. So x is equal to 4. And RQ was represented as x, so we found what RQ is by finding our x value. That is 4. Here's another example. This time we have a tangent to the circle and a secant. And I see that it's talking about length in the question. The length of tangent AD is 24. They tell us the ratio of DC to CB, the segments, is 4 to 5. So DC would be the 4 part of the ratio, and CB would be the 5 part of the ratio. And we need to find the length of CB. So after we find what x is, we can plug in and get what the length of CB is, because it's 5 times x. So since we have a secant and a tangent, and we're talking about the lengths, we're going to be using the same rule that we just did before for the lengths of secants and tangents. Whole times outside equals to whole times outside. So let's start with the tangent. So the whole tangent is 24, and the whole tangent is actually located entirely outside of the circle. So when you have a tangent, since it's completely outside the circle, the whole and the outside are going to be the same thing. So the outside part is once again the whole thing, which is 24. And over here on the secant, the whole thing is 5x plus 4x. So that is 9x times the outside part, which is 4x. So using my calculator, 24 times 24 is 576. And then we have 36x squared. Now, if I divide 576 by 36, I get 16 is equal to x squared. And I can easily simplify this by taking the square root of both sides. And I have x is equal to 4. So the question was asking me for the length of CB, so don't forget to plug back in. 5 times 4 would be 20, so the length of BC or CB is 20. Here's another example that's going to combine a lot of the stuff that we did so far. And this question is talking about angles. So we have PA, which is tangent to the circle. We have chord AC. We have secant, PCED. And we have chords AOB and CD that intersect at point E. So we got it all going on here. We have tangents, we have secants, we have intersecting chords, we have everything that we just spoke about in this video. If arc AD is 130 degrees and measure of angle BAC is 50 degrees, find angle P, angle BEC, and angle PCA. Please pause the video and try it yourself so you can see if you understood what we talked about in this video. Okay, so first we need to find a measure of angle P, which is an outside angle, and we know that outside angles are equal to half the difference of their intercepted arcs. So we have this as one of its intercepted arcs, and we have this as one of its intercepted arcs. Those are the arcs that are inside the rays of the angle. So the problem is that we don't know this piece of the arc. And if we were finding the angle, that would be two unknowns. But I do have this 50-degree angle, which is an inscribed angle. And I know inscribed angles are half their intercepted arcs. So if the inscribed angle here is 50 degrees and it intercepts arc BC should measure 100 degrees. And then since from B to A is half a circle, it's 180 degrees. So that means the remainder over here needs to be 80 degrees to make 180 degrees. And now I am all ready to get started with finding angle P. Angle P is equal to half the difference of big arc minus small arc. And if I use a calculator, 130 minus 80 is 50, and half of 50 is 25 degrees. So we answered the first part of the question. Angle P is 25 degrees. The next part is to find the measure of angle BEC, which is one of the vertical angles here formed by the intersecting chords. And remember, the vertical angles are equal to half the sum of their intercepted arcs. So one of the intercepted arcs would be 100, and the other one for these two angles would be 130. So 100 plus 130 is 230, and then if I take half of that, I get 115 degrees for the vertical angles. So let me put that in here. And then the last one that we need to find is the measure of angle PCA. So this angle over here is an angle formed by a chord and the tangent to the circle. And notice its vertex is like on the circle. So it kind of reminds you of an inscribed angle, and it works the same way. It's going to be half the arc that it's touching, that it's opening up to. So if this arc over here is 80 degrees, then that makes this angle 40 degrees because it works the same way as an inscribed angle.